Continuing our discussion on composition of functions, here's another problem I want to look at. And this is number 11 in your homework. For the given pair of functions, find f composed with g of x and g composed with f of x. Is f composed with g of x equal to g composed with f of x? Under normal circumstances, we said composition of functions is not commutative, so usually f composed with g does not equal g composed with f. Just the fact that they're asking that makes me think it might be equal. Okay, well, let's find it. And it's not as bad as it might look at first glance. The fractions and radicals may look awful to you, but it's really not that bad. So let me rewrite the functions. We have f of x equals the cube root of 7x plus 4, and g of x equals 1/7 x cubed minus 4/7. Let's find f composed with g of x first. This is part A. F composed with the g of x. What letter's on the outside? F is on the outside, and on the inside I have, okay, g of x, the 1/7 x cubed minus 4/7. This is saying go to the function f. Wherever you see a variable, plug in 1/7 x cubed minus 4/7. So we come up here to the function f. We have a 7. We're going to replace the x with the 1/7 x cubed minus 4/7. Do we have anything else under that radical? Okay, I agree, the plus 4. Don't forget that. We came up to f, and we replaced the x with that red stuff, 1/7 x cubed minus 4/7. Now let's simplify. Distribute the 7. Something nice is about to happen. When you distribute the 7, you won't have any fractions left over there. Distributing the 7, we're going to have an x cubed minus, distributing the 7 there and there, you have an x cubed minus 4, and you still have the plus 4. Negative 4 plus 4, what's that going to become? 0. So the cube root of x cubed, what does that reduce to? No. Now, wait a minute. The cube root of x cubed reduces to just x. The cube undoes the impact of that radical. So the answer for part A is just x. I'll write it right up here. The answer for part A is x. Now part B, they want us to find g composed with f of x. G composed with f of x. And this event, g is on the outside, and f of x, that cube root of 4x plus 7, not 4x, 7x plus 4. Have I been saying that backwards? It's 7x plus 4. I don't know why I said 4x plus 7. So g is on the outside. The cube root of 7x plus 4 is on the inside. What's this notation saying to do? We go to the function g, and wherever we see a variable, we're going to plug in. We're going to go to the function g, and wherever we see a variable, we're going to plug in the cube root of 7x plus 4. So we have a 1/7 replace the x with the cube root of 7x plus 4. Is there anything else we have there? Came up here, we replaced the x. Is there anything else out here? Yes. A cube and minus 4/7. And this reduces very nicely. The cube root being cubed, what impact does the cube have on the cube root? Cancels out, so all you have is 1/7 times 7x plus 4 minus 4/7. Distributing the 1/7, we get x plus 4/7, and we still have a minus 4/7. Oh, what's this gonna reduce to? Just x. So the second one reduced to x as well. We come up here, g composed with f of x. It also reduced to x. Were the compositions equal, yes or no? Yes. If the composition of two functions reduces to x in both directions, we say that the functions are inverses, and we'll be seeing that. Let's see, I guess your test is, no, okay, we'll be seeing it right after your upcoming test. 1 week from today, we'll probably start it. I think a week from today. And I'll say, remember that number 11? If the composition reduces to x in both directions, the functions are inverses. But I'll remind you of this problem in a week's time when we're looking at inverse functions. Any questions?